Right, so we're going to look at solving a simultaneous equation with one linear and another quadratic or circle. So in this case, it says solve the simultaneous equation, or they could write find the point of intersection between. So if we look at the question they've given us, this first graph, our first equation, is a linear equation because it's just x. There's no x to the power of anything. And the one underneath it has a power, okay? So if it just had an x squared, we know it would just be a quadratic. But the fact that it has y squared as well, it's actually a circle if we drew that. X squared plus y squared is equal to 34, so you should know that's a circle with the centre 0, 0 and the radius root 34. So this all aside, we have to find the point of intersection between this linear and this quadratic, or circle in this case. So I have my steps written over here, so you need to know these steps off by heart. So our first step is to get the linear in terms of x or y. So as I said before, the linear equation was x plus 4y equals 17. So get in terms of x or y, so that means you want x equals or y equals. It'd be far easier in this case to get x equals because there's a 4 with the y, so that if we were to get y on its own, we'd end up with a fraction. So we get x on its own, it'd just be 17, and we'll bring across the 4. So it becomes a minus 4y. So that is our linear on its own. Once we've done that much, our second step is to sub this linear back into the quadratic or the circle. So we know the quadratic is x squared plus y squared equals 34. So now we have to sub in, instead of x, we're going to put in 17 minus 4y. So we'll have 17 minus 4y all squared plus y squared is equal to 34. Okay, so 17 minus 4y, you're going to have, that's 17 minus 4y squared, means it's on 17 minus 4y, plus y squared equals 34. Be careful there, that's where a lot of people go wrong. They end up saying 17 squared minus 4y squared. But you have to remember, a square bracket means the bracket's written twice. So do that and then split your brackets. So we'd have 17 and 17 minus 4y and 17 minus 4y plus y squared equals 34. So 17 by 17 will give us 289. 17 by 4 minus 4y will give us minus 68y. 68y plus 16y squared plus y squared equals 34. You can see that you're going to end up having a y squared, a y, and a number equals 0, so it's going to be a quadratic equation. So you should be able to already see this, so you know you'll be solving by opening your brackets or your minus b formula. So we'll put our squares first, so we'll go 16 squared plus 1y squared, 16y squared, plus 1y squared will be 17y squared. Minus 68 will give us minus 136y. Plus 289. Bring across your 34 because you know your equation is always going to have to equal 0. So bring across it. So you'll have 17y squared minus 136y and 289 minus 34 will give us 255. So what you've done is you got your linear in terms of x or y and you subbed it into the quadratic or the circle. Then you just multiplied it all out, simplified it, and you end up with an equation with a y squared, a y, and a number. So you know you're going to be opening your brackets because it's quadratic trinomial. At the minute it looks really difficult to open our brackets because there's 17y squared, so I'd be thinking minus b formula. Before I'd always try my minus b formula, I'd check, can I divide across by something to make this equation, to simplify this equation. So does 17 go into each of these things? So we'll try 136 divided by 17. It goes 8 times, great. So, and then 255 divided by 17 goes 15 times, perfect. So it does. So I'm going to actually divide across by 17, and I might not have to use my minus b formula then at all. So 17 divided by 17 just leave us with y squared. 136 divided by 17 it gives us 8y, and 255 divided by 17 gave us plus 15 equals 0. Now it's much simpler to actually, I don't need my minus b formula, I can actually just open my brackets. You're going to get the exact same answer if you do use minus b formula, so don't worry if you do. So you'll have y and y. So factors of 15. So we have 1 by 15, 3 by 5, and that's it. Because then our next factor is 5 by 3, which we already have down. So which one of these would give us an 8? So it's going to obviously be 3 and 5. So we put in our factors 3 and 5. So we know we're working for a minus 8. So we'll do inside, inside, we'll end up with 3y. Outside, outside, we'll end up with 5y. And we want to get a minus 8y. That would mean that both signs will have to be negative. So to solve, we're going to have y minus 3 equals 0, y equals 3. And then y minus 5 equals 0, y equals 5. So we've got our two values. So we just go back up to our steps. So what we've done so far, we've got our linear in terms of x or y. We've subbed it back into the quadratic. We've solved for the unknown, so in this case we found y. And now we must sub it back into the initial linear equation to find the other unknown, which is finding x. So we just sub our y value back into our linear equation to find x. So 4 plus, x plus 4y equals 17. Just ignore that. So x plus 4y equals 17 was our linear equation. So what we're going to do is going to let y equals 3 first because of up here. So we'll have x plus 4 times 3 equals 17. So we'll have x plus 12 equals 17. X is equal to 17 minus 12. X is equal to 5. So that point is going to be 5, 3. So we know our linear meets that circle. Whatever, it could be 5, 3. And then there has to be a second value as well. If there was only one value of where it met, it would be a tangent. Don't forget that. They meet at one spot. That wasn't very well done. Something like that. But we had two values. So now we're going to let y equals 5. So we'd have x plus 4 bracket 5 equals 17. X plus 20 equals 17. So x is equal to 17 minus 20 because 20 comes across. X is equal to minus 3. So that's our point minus 3, 5. So they are our 2 points of intersection between a linear and a quadratic, or in this case a linear and a circle.